today's world, technology powers almost every part of our lives. But have you ever wondered what impact do our laptops, mobiles, or desktops have on the environment? This is where green computing comes into play. It is all about making technology sustainable, efficient, and eco friendly. The IT sector consumes massive energy from manufacturing devices to powering data centers. According to reports, e waste is one of the fastest growing waste streams in the world. A record 62 million tons of e waste was produced in 2022, an 82% increase since 2010. This is expected to rise to 82 million tons by 2030. What's more, billions of dollars worth of valuable resources are squandered, and only about 1% of the rare earth metals demand is currently met by recycling e waste. That's why Green IT focuses on reducing carbon footprint, increasing energy efficiency, and promoting sustainable practices in computing. To measure all of this scientifically, we use life cycle assessment or LCA. LCA is a method to calculate the environmental impact of a product from its raw material extraction to manufacturing, transportation, usage, and finally disposal. Analyzing LCA of IT devices is critical. A product may seem eco friendly during usage, for example, a laptop consuming less power, but if its production involves heavy mining, toxic chemicals, or high emissions, then overall it may not be suitable. And this is where openLCA comes in. It is a free and open source tool widely used by researchers, industries, and students to model life cycle processes, input data sets, and generate impact reports. So, let's get started on how openLCA works. The first step is downloading the software. OpenLCA is available on its official website. It is completely free and an open source software, and you can install it like any other application. Once installed, it opens up with a simple interface that looks a lot like a project workspace where you can create, manage, and analyze life cycle models. Think of openLCA as a kind of simulation lab where we are not testing chemical reactions or circuits, but the environmental reactions of our products through the life cycle. After downloading the openLCA setup, you will see a dialog box guiding you through the installation. Once the installation is complete, our openLCA application setup is done. Now I'll head over to the openLCA official website. Here we'll quickly scroll to show you the different sections. At the top, there is a search bar where we can look for anything we need. To proceed further, we'll need to log in. If you do not already have an account, you'll have to create one. Once logged in, we go to the databases section. Here you'll find a wide range of databases available. Since we are working on the HDD project, we'll need the ELCD database. To get it, we'll go to the download section and then to the corresponding ELCD checkbox, we'll click on tick for the same and agree to the license terms and then click on download. The download will automatically begin, and once completed, we can install this and add this database into our openLCA system. This database contains thousands of processes covering materials like steel, aluminium, plastics, electricity generation, and waste treatment. Without this, openLCA would just be an empty shell. The database is what gives us the background data we need to model real world products. Now that our database is ready, the next step is to set up the flows and processes. In openLCA, a flow represents the material, energy, or waste that enters or leaves a process. A process defines the transformation, production, or disposal activity that uses these flows. To create them, we'll go to the flows section, right click, and then select new flow. After creating a flow, we move on to the process section. Here we create a new process and link it with the flow we just defined. Once both are created, we'll see on the right hand side two tabs, inputs and outputs. Here for each input flow, we double click and on a cell and add the required material or resource along with its quantity. For example, steel, aluminium, electricity, transport, waste incineration, etc. Based on the reference list we prepared, here is a screenshot of the list that we just prepared. This way, we gradually build the full inventory of materials and energy needed for our HDD LCA model. Now, what we have to see is that the central box represents the HDD LCA process. On the left are all the inputs, that is aluminium, sheets, steel bars, electricity, transportation, and waste incineration of all the plastics. Each of these inputs come from the ELCD database, which gives us realistic values. For instance, like here we had taken aluminium to be 0.15 kg, steel to be 0.35 kg, electricity to be 25 kilowatt hour, and plastic waste incineration to be 0.8 kg, and many more. So all of these flows are connected to the HDD process. On the output side, we simply define HDD LCA as one item, which means that this model represents one hard disk drive. This structured network allows us to capture the entire life cycle chain, from production of materials to manufacturing energy to transportation and finally to waste treatment. Now comes the interesting part where we are going to be building the product system. That is, after defining the process, the next step was to generate a product system. And this connects the HDD process to all its upstream supply chains and prepares the model for calculation. openLCA automatically links the inputs to their providers, creating a network of processes. But what we have to make sure is that when we are creating all these processes, we select a provider for the same when we are selecting them from the input in our input database. Now, once all of that is done, we have a look at the results. So the general information tab will tell us about that the openLCA generated graphs highlighting the top 5 direct contributors to impact categories and the top 5 flow contributors. These show which materials or processes dominate the environmental burden. When we go on to the inventory results tab, here we can see the total resource requirements, emissions, and energy use across the life cycle of the HDD. When we go to the impact analysis tab, here we can see the software calculates how much energy each category contributes in terms of global warming potential, acidification, eutrophication, and other equivalents, which we can keep checking by clicking on the drop down menu and choosing the right option. For example, electricity and aluminium production were one of the major contributors to carbon emissions. Process results. This section breaks down inputs and outputs for each process, helping us identify hotspots. Now we move on to the Sankey diagram tab. Here it is one of the most visual results. It shows flows like aluminium, electricity, and transport feeding into the HDD. The thickness of the arrow represents its percentage contribution to the overall impact. This makes it very easy to see which materials dominate. Now, when we look on to the model graph, here we can see that finally the model graph displays the supply chain as a flowchart, showing how inputs like hydroelectric power or steel production link to the HDD process. This provides a clear overview on the interconnected processes. So, in conclusion, to sum it up, green computing is not just about energy efficient devices, but about looking at the entire life cycle of technology. LCA, through tools like openLCA, provides a scientific framework to measure and compare environmental impacts. By modeling something like an HDD, we can clearly see that the materials, energy, and waste involved and use that knowledge to improve sustainability. In the bigger picture, these methods guide industries, governments, and even us as individuals to move towards more responsible and eco friendly choices in technology. Green IT and lifecycle assessment together pave the way for a future where our laptops, smartphones, and servers not only connect the world but also protect it. And finally, before we wrap up, here is a QR code. If you scan this code, it will take you to a document where we have included all the references that we used for this project. You will also find additional materials such as the screenshots of our results, the list of elements we considered, and even the Excel sheet containing the detailed output data from openLCA. So if you would like to explore the results in more detail or revisit the sources, you can simply scan the QR code and access everything in one place.